The universe is unimaginably vast. I mean, really, truly vast. Most stars have planets. We're finding new exoplanets all the time. So why haven't we met any aliens yet? This is the Fermi Paradox. Are we truly alone? To grasp the Fermi Paradox, we need to understand the universe's scale. Imagine our Milky Way, a city of billions of stars. Now imagine trillions of galaxies, each with countless stars and planets. It's enough to make your head spin. So where is everybody? The Fermi Paradox has puzzled scientists and philosophers for decades, leading to a plethora of theories and explanations. Some believe that the vast distances between stars and galaxies make interstellar travel and communication practically impossible. Others propose that alien civilizations might be intentionally hiding from us, perhaps observing us from afar, like we study animals in a zoo. Could it be that we haven't been looking long enough? Or that our technology is simply not advanced enough to detect their signals? Or maybe, just maybe, the conditions for intelligent life to arise are so incredibly rare that we truly are alone in this vast cosmic ocean. Now, I'm an optimist. I like to believe that we're not alone in the universe. There are billions of years of cosmic history that we haven't witnessed. It's entirely possible that civilizations have risen and fallen long before humans even walked the earth. Perhaps they're out there, sending out signals as we speak, but we just haven't developed the technology to detect them. Imagine an ant colony trying to understand the internet. They might see the cables and wires, but they wouldn't even begin to comprehend the vast network of information flowing through them. Our current methods of searching for extraterrestrial intelligence might be similarly limited. Chapter 4. Space is too big. Let's face it, space is unimaginably vast. The distances between stars are so enormous that even traveling at the speed of light, it would take years, centuries, or even millennia to reach even the closest star systems. Imagine trying to send a message to someone on the other side of the world using smoke signals. It would be incredibly difficult, if not impossible, to get your message across. Now, magnify that difficulty by billions of times, and you begin to understand the challenge of interstellar communication. The sheer scale of the universe might be the single biggest obstacle to finding our cosmic neighbors. Chapter 5. We're using the wrong technology. For decades, we've been searching for alien life using radio telescopes, hoping to pick up artificial signals from distant civilizations. But what if advanced aliens have moved beyond radio waves? What if they're using forms of communication that we haven't even dreamed of yet? Imagine trying to explain the internet to someone living in the Middle Ages. They wouldn't have the framework to understand it. Similarly, our current understanding of physics and technology might be limiting our ability to recognize alien signals. It's like trying to catch a fish using a butterfly net. We might need a completely different approach to reel in that cosmic catch. Chapter 6. We haven't been looking long enough. Our search for extraterrestrial intelligence has been relatively short. We've only been listening for alien signals for a few decades. That's like dipping a toe in the ocean and concluding there are no fish. The universe has been around for billions of years. It's possible we've just missed the party. We need to be patient and expand our search. The universe is full of surprises. Keep looking. Chapter 7. Now this is where things get really interesting. What if aliens are intentionally hiding from us? It might sound like something out of a science fiction movie, but there are compelling reasons why an advanced civilization might choose to stay hidden. Perhaps they're protecting themselves from potential threats or avoiding interference with less developed cultures. Imagine stumbling upon an anthill. You wouldn't necessarily want to destroy it, but you also wouldn't want to disrupt the ant's way of life. Maybe aliens view us in a similar light, observing us from a distance, waiting for us to reach a certain level of technological or social maturity before making contact. Chapter 8. Here's a sobering thought. What if intelligent life is incredibly rare in the universe? The conditions that led to life on Earth, and ultimately to intelligent life, might be so incredibly specific, so astronomically improbable that we're the only ones who won the cosmic lottery. Think about all the factors that had to align perfectly for us to be here. The right kind of star, the right distance from that star, a stable planetary system, liquid water, a protective atmosphere. It's a long shot, and it's possible that we're the only ones who beat the odds. Chapter 9. The Great Filter Hypothesis is a chilling possibility. It suggests that there's a barrier, a filter, that prevents most civilizations from reaching a certain level of technological advancement, often leading to their own demise. This filter could be anything: a natural disaster, a technological singularity that spirals out of control, or even self-destruction through warfare or environmental degradation. If the Great Filter Hypothesis is true, the big question is, where are we in relation to that filter? Have we already passed it, or is there a catastrophic hurdle waiting for us in the future? We often take for granted how perfectly suited Earth is for life as we know it. Our planet exists in what we call the Goldilocks zone, not too hot, not too cold, just the right distance from the sun for liquid water to exist. We have a protective atmosphere, a magnetic field that shields us from harmful radiation, and a moon that stabilizes our planet's rotation. It's possible that these conditions are incredibly rare, making Earth a cosmic oasis in a vast, inhospitable desert. History has shown us time and again that intelligent civilizations can be their own worst enemies. We've seen empires rise and fall, often due to internal conflicts, resource depletion, or environmental degradation. It's possible that this pattern repeats itself on a cosmic scale. Perhaps advanced civilizations develop the technology to reach the stars, only to destroy themselves before they ever get the chance. If this is the case, it's a sobering reminder that technological advancement doesn't necessarily equate to wisdom or long-term survival. Technology is a double-edged sword. It has the power to solve our greatest challenges, but it also has the potential to destroy us. Imagine a civilization developing artificial intelligence so advanced that it surpasses human control, or creating weapons of mass destruction capable of wiping out entire planets. Technological advancements, if not managed responsibly, could be the very thing that leads to our downfall, preventing us from ever reaching the stars or encountering other intelligent life. Chapter 13. The universe is a dangerous place. Asteroids, gamma-ray bursts, supernovae, these cosmic events have the power to obliterate entire civilizations in an instant. It's possible that life on other planets has been repeatedly extinguished by these cosmic disasters, preventing any single civilization from achieving long-term survival or interstellar travel. It's a humbling reminder that even the most advanced civilizations are ultimately at the mercy of the universe's capricious nature. Chapter 14. Perhaps the most intriguing possibility is that aliens are aware of our existence, but they're choosing to avoid contact. This idea, known as the zoo hypothesis, suggests that Earth is being treated like a nature preserve, with advanced civilizations observing us from afar, studying our behavior, and perhaps even influencing our development without directly interfering. It's a fascinating, if somewhat unsettling, thought that we might be living in a cosmic zoo, completely unaware of our caretakers. Chapter 15. Imagine a group of scientists studying a colony of ants. They wouldn't want to disrupt the ants' natural behavior, so they'd observe them from a distance, using hidden cameras and sensors to gather data. The zoo hypothesis suggests that advanced aliens might be doing the same thing to us, observing our progress, studying our culture, and perhaps even intervening subtly to guide our development. It's a thought-provoking idea that raises profound questions about our place in the universe and the nature of intelligence itself. The Fermi Paradox is a constant reminder of the vastness of our universe and the mysteries it holds. Are we alone, clinging to our little blue planet? Or are there other intelligent beings out there waiting to make contact? The truth is, we don't know, but the search for answers continues. Scientists are constantly pushing the boundaries of technology, searching for faint signals from distant stars, studying exoplanets for signs of life, and developing new ways to explore the cosmos. The Fermi Paradox is a puzzle that may never be fully solved, but it's a puzzle that inspires us to keep exploring, keep questioning, and keep looking up at the stars with a sense of wonder and possibility.